So this is lesson number 92 in Algebra 1, and this has to do with uniform motion problems about equal distances. And if you remember from math years ago, you learned a formula, which is distance equals rate times time. So if you want to know how far it is to Anchorage, and you're going 60 miles an hour for 3 hours, if you multiply those, you go in 3 hours 180 miles. Okay? So that's what d equals RT is. It can also be written several ways. We can write it, let's say that we're looking for speed, like right here. Well, if we divide by 3 and divide this side by 3, 180 divided by 3 gives us our 60. So the rate equals distance over time. So distance equals rate times time, rate equals distance over time, and time equals distance over rate. So if you say you go 150 miles and you're going 50 miles an hour, if you divide those, it will take you 3 hours to get to where you're going. Okay, so that is the d equals RT part of this lesson. Now what we're going to do is we're going to look at some story problems that deal with distance, rate, and time. We're going to look at two different kinds. The first one is going to be somebody goes this distance and somebody else goes that distance. So the distance of the first person equals the distance of the second person, or the second method. So let's say that you ride your bike and it takes you this long, and you walk and the same distance and it takes you a different amount of time. So one distance equals the other distance. The other one we're going to look at is the distance getting there. Let's say you rode your bike somewhere and you got a flat tire and you had to walk home. So the distances are the same, you're just going in opposite directions. Alright, so let's look at the first example, and the best way to explain these is to use examples. So on Tuesday, the express train made the trip in 12 hours. Okay, so we made this trip all the way there. So the distance of the express train, so the time of the express train, I use a little e there, was 12 hours. On Wednesday, the freight train made the same trip. So we've got a freight train, so we'll say the distance of the freight train. And they're equal because it says it made the same trip. And it took 16 hours. So the time that it took the freight train was 16 hours. Okay, so the distances are the same, but the times were different. It says here, find the rate of each train if the rate of the freight train was 15 kilometers per hour less than the rate of the express train. So the rate of the express train and the rate of the freight train. Now what do we know? We know that the freight train speed was 15 less than the express train. So let's call the express train speed, RE. The rate of the freight train would be the speed of the express train minus 15. It was 15 slower than RE. Okay, so that's some information that we know. We know the rate of the express train, the rate of the freight, the time of the express, and the time of the freight. We also know that these two distances are the same. The distances of the express train is the same as the distance of the freight train. Okay? So what do we know about distance? Distance equals RT. So if we take the distance of the express train, that's going to be its rate times its time. If we take the distance of the freight train, that's going to be the rate of the freight train times its time. So if these are equal, then that means these have to be equal. Okay? Because the distance of the express train equals this. So if these two are equal, then we can take this, RT, and plug it in for here. We can take this and plug it in for here. So that means that we end up with, let's move that out of the way, the distance Now let's move this back for right now. We're going to be interested in the RT of the express train, and we're going to say that equals RT of the freight train. So R of the express train is RE, we don't know. The time of the express train is 12. And that equals the rate of the freight train, which is equal to RE minus 15, times the time of the freight train, which is 16. Alright, everything else we can get rid of because all we care about is this equation right here. So we have, let's switch these around and make it 12RE equals, we're going to distribute this. So 16 times RE is 16RE. 16 times 15 is 256. I think it's 250. Let's try, or 240. Let's try this just to make sure. That's for 240, yeah. Minus 240 when we distributed the 16 to the 15. Alright, let's move this over there. 12 minus 16 is negative 4RE. That equals negative 240. Now, remember, when you have one term here and one term here, you can just flip the signs over and you're good. So 4RE equals 240. So all I have to do is divide this by 4 and this by 4, and my RE equals 60. Alright, what do I know about my freight train? Because I'm supposed to find both. My freight train was 15 less than 60. So that equals 45. So I've got my two answers there. So all I'm doing is I'm comparing my rates and my times together and getting an answer. Alright, let's try example 92.2. Alright, so what do we have? The members of the girls' club hiked to Lake Tenkiller at 2 miles per hour. Alright, so they hiked. Mr. Ali gave them a ride back home at 12 miles per hour. Find their hiking time if it was 5 hours longer than their riding time. Okay, so we're supposed to be finding their hiking time and how far it was to Lake Tenkiller, or Tenkiller. Alright, so we have this bunch of girls, and they start here and they hike. So they hike a certain distance. When they get there, this creepy guy gives them a ride back. So the distance hiking is the same as the distance riding, correct? They just went opposite directions. So if distance equals RT, I can say that the distance hiking is the same as the rate hiking times the time hiking, and that equals the rate riding times the time riding. So I just changed it from D equals D to RT equals RT. Since D equals RT, whenever I see a D, I can replace it with RT. Alright, now let's see what kind of information they gave us. Alright, they hiked at 2 miles per hour. So our time hiking, let's put this up here. 2 miles an hour, that's not really very fast. He gave them a ride back at, oh, I'm sorry, not time hiking. What am I doing? That's how fast they were going, isn't it? So their rate hiking is 2. Their rate riding is 12 when they got with the creepy guy named Ali. Find their hiking time if it was 5 hours longer than their riding time. So their riding time, we're going to leave that, oops, let's make it, their riding time riding is going to be, we're just going to leave that as that. But their time hiking, what does it say about that? It was 5 hours longer. So it's going to be however long it took to ride plus 5 hours. So what do I have? I've got the time hiking, the time riding, the speed riding, and the speed hiking. So let's put those together. Our h is 2. TH is TR plus 5 equals the rate riding 12 times TR is just going to be TR. Okay? So 2TR plus 10, distribute that 2, equals 12TR. Change colors here. Alright, let's move this over. So we have 10 equals 12TR minus 2TR, which is 10TR. Divide by 10, divide by 10, and the time riding was 1 hour. So we found that. So we were supposed to find what? Find their hiking time if it was 5 hours longer than their riding time. Well, their riding time was an hour, so that plus 5 is going to give me a time hiking of 6. And how far did they go is the next thing. How far is it to Lake Tenkiller? It is, let's see, 12 miles per hour is how fast the creepy guy Ollie went, right? 12 miles per hour, and how long did he go? 1 hour. So how far is it to Camp Tenkiller? 1 hour from here to here, because he went 1 hour at 12 miles an hour. So it was 12 miles total. Okay, so that's it for 92.2. Let's do one more. Alright, so Durant got to the oasis in 2 hours. So Durant's time of Durant, is 2. And then we've got Medill, who walked, and it took him 10 hours. So, took him 10 hours. Okay, so that was to walk. Alright, so that's the distance of Durant and the distance of Medill. How far is it to the oasis if Durant drove 16 miles an hour faster than Medill walked? So the rate of Durant and the rate of Medill. Alright, so Durant drove 16 miles an hour faster than Medill. So Medill, he went his speed, Medill's speed, and Durant went 16 miles an hour faster. Okay, so how far is it to the oasis? So we're looking for this distance right there. So again, dd equals dm. R, the rate of Durant times his time, equals the rate of m, Medill, times his time. So RD is going to be 16 plus RM from here, times TD, which we said is 2, equals the rate of Medill times his speed, which was 10. So distribute 32 plus 2RM equals 10 RM. Subtract, and we have 32 equals 8 RM. Divide by 8, divide by 8, and the rate of Medill then is 4. So that's how fast Medill went. What are we looking for? How far is it? Well, if he went 4 miles an hour for 10 hours, that means it's 40 miles. Okay, so that is it for lesson number 92, Algebra 1.